HTTP methods are the verbs of the internet. They tell servers what action you want to perform with your data. So every time you interact with a website or an API, you're going to be using an HTTP method whether you realize it or not. They're the fundamental commands that make the web interactive rather than just readable. So when you browse, say, Instagram, different methods are going to work behind the scenes. So loading your feed will use a get to retrieve posts. Maybe liking a photo uses a post to create that like. Maybe editing a comment is going to use like a put or a patch to update it. And deleting a story is obviously going to use delete. So these methods they're kind of like the universal language that servers are going to understand. And in automation, choosing the right HTTP method is going to be crucial, really. It's the difference between reading data or accidentally deleting it, which you don't want to do. So when you use NAN's HTTP request node, for example, there's a drop-down menu that is asking for either a get, a post, a put, delete. It isn't just technical jargon there. It's asking, what do you want to do with this data? And the methods exist because servers need really clear instructions on what it is you want done. A single API endpoint like customers could show all the customers. It could create a new customer. It could update existing customers, or it could delete them. And so the HTTP method is the information that goes along to tell the server which of the actions you actually intend. Without the methods, the servers wouldn't know if you're just browsing or if you're making changes. HTTP methods work like actions in a library. So get is like browsing. You just walk in, you look at some books, maybe you read them, but you don't really change anything. And you could get a specific book, maybe by its ID, or you could get a list of all books in a certain category. The library remains exactly as you found it. There's nothing changed. Post is like donating a book to the library. You bring something in that didn't exist there before. The library assigns it a catalog number and maybe finds it a spot on the shelf, where it's going to go. So you've added to the collection. Each post is going to create something new. A put is like replacing a damaged book with maybe a new copy. So you specify exactly which book to replace, and then you provide the complete replacement, the whole thing. So the catalog number would stay the same, but the physical book is entirely new. And a put replaces just the whole thing pretty much. So delete is pretty straightforward. It's removing a book from the collection entirely. And once it's deleted, that catalog number wouldn't exist anymore either. So the book's just completely gone from the system. A patch is like fixing a torn page in an existing book. You only change the damaged part, leaving everything else untouched. This library system kind of ensures that everyone understands what happens to the collection itself. So just like librarians need to know if you're browsing or changing their inventory, servers need these HTTP methods to really understand your intentions. Get retrieves data without changing anything, so it's safe to use repeatedly, just over and over again. You can get the same data 5 times. It has no side effects whatsoever other than the usage. Get requests can include parameters maybe in the URL to filter results, like you might have get products where the category equals electronics, just to see electronic category items. The data you want comes back in the response body for the request. A post is going to create new resources, so you send that data in the request body, and the server is going to create something new with it. So if you are posting to, say, orders, it's going to create a new order. The server usually returns the created item itself with its new identifier. So unlike get, repeating a post is going to create multiple items. So 5 post requests create 5 new orders in that instance. Put replaces entire resources. You need to know the exact resource identifier and send complete replacement data. So if you had put customers 123, then it's going to replace all data for customer 123. If you only send the name, then the customer loses maybe their email and phone number. So put expects complete data. Delete, again, is going to just remove the resources permanently. So if you had delete products 456, then product 456 is completely gone. It's a simple but irreversible. And patch updates partial data. So you got, say, patch uses 789 with just an email, then it's just going to update only that field, leaving your name and other preferences untouched. Patch is really forgiving for partial updates. NAN is going to provide multiple input options. You get raw data, form data, building objects, field by field. And the node preview is going to show your complete request, making it clear what data is actually going to go through and send, and how it's going to be formatted in that JSON request. Get responses typically show arrays of data or single objects. Post responses often include the created resource with its new ID, or maybe just the ID by itself. Delete responses might be empty with just a success status, or they might have the identifier of what was deleted. Understanding these patterns really helps you handle the different responses correctly in the subsequent nodes that you have after it. The biggest mistake that beginners make is using GET to send data. So GET requests shouldn't have bodies generally. It's all data is going to go in the URL. If you need to send complex data like customer details or file uploads, you're going to use a post or a put. Inner N is going to warn you if you try adding the body to a GET request. Using a post request when you mean put creates duplicates. If you post the same customer data 5 times, you get 5 different customers all with the same data. Put to a specific ID updates, just that specific customer. So you have to check if you're creating new records or if you're updating existing ones before you choose the method that you're going to use. And delete is permanent. There's no undo when you use that option. So accidentally using delete instead of GET could really wipe out a lot of data. In inner N, you want to add confirmation steps before delete operations. So you might want to use the if node to check conditions, maybe requiring specific values or user confirmation before allowing that kind of deletion. And many APIs use patch for updates, but beginners will often send complete objects like with put. So patch, you just remember it means sending only the changed fields. If only the email changed, just send the email key with the email value, not the entire user object again, even with empty values. This prevents accidentally overriding data with like empty values or null values and reduces your bandwidth usage. E-commerce APIs demonstrate all methods pretty clearly. So you'd have GET for products, that's going to list all the products in your store. So something like GET products 123 shows details for that particular product. And post products with like a name, a price, and a description is going to create a new product for you. The API is going to return the new product with its generated identifier. In customer management, it follows similar patterns usually. So it might be GET customers, maybe country equals US, and that's going to filter to only the US customers only. Post customers, it's going to create a new customer account. A put customer 456 is going to completely update customer 456's record, but a patch for customer 456 just updates maybe their shipping address or billing address. And then a delete for customer 456 is just going to get rid of them entirely. So payment APIs restrict methods for security, so you can usually get transaction histories and maybe individual transaction details. Post is going to create maybe new charges or refunds, but you typically can't delete transactions because financial records need to be immutable, so that they can't be deleted basically or changed. So some endpoints only support specific methods based on the business logic that's behind it. So Webhook APIs often use just post. When Stripe sends payment notifications or GitHub reports new commits, they post data to your endpoint. So your inner N Webhook node is going to receive these post requests. So in Webhook requests, you need to have the HTTP method there as well for incoming posts. It helps you troubleshoot when they don't appear. So maybe your endpoint only accepts GET requests rather than post. Always check API documentation first before you start developing against these HTTP methods. You want to look for descriptions that explicitly state which methods are supported. So good documentation is going to show examples for each method separately, including the required parameters and generally the expected response as well. In NAN, you want to keep your documentation pretty open while you're building workflows to reference the correct methods. And you want to follow RESTful conventions when you're unsure. So I'll talk about that in another video. Collection endpoints like users typically support GET for listing and then post for creating. Maybe specific endpoints like users 123 would support like GET for reading, maybe a put or a patch for updating, and then delete for removing. And these patterns work across most modern APIs now. You want to test always just with a GET first when you're exploring a new API. It's just the safest method. You can't accidentally modify any data. So once you understand the data structure and the response format, then you can move on to some of the other methods that make changes, like the put, the patch, and the post. Inner-end's ability to preview requests without running them really helps to prevent accidents from happening as well. And then consider methods that can be safely repeated. So some methods like the get, put, and delete have pretty much the same result whether you do them once or multiple times. Pressing delete twice doesn't double delete. Post and patch obviously create new things or add changes each time. And in workflows that might like retry on failure, you want to just take that into account, because understanding that helps prevent creating duplicates or applying those changes multiple times by accident.